Hello, everybody. My name's Connor Lennon. Thank you very much for your patience. I know it's been a bit of a while, and we're just still waiting for one school. But as we have one of our pilots here now, André Borschberg, I think it's best if we get started because the pilots are extremely busy. I'll first say hello to André, see if he can hear us. Hello, André. Okay, I can hear you as well, André. Yep, I can hear you loud and clear, André. Thank you very much. Okay.
Okay, so good morning and good afternoon to everybody.
Okay, so we'll get started then. We'll just mute you for a second, André, because there's quite a lot of background noise there from the hangar. We can see the aeroplane behind you, just about. And so welcome to everyone. We have academies and schools from Hyderabad, Rajasthan, Goa we have as well. We've got the Aditya Birla World Academy and the Sardar Birla Academy. Well, I'm speaking to you from Monaco. As you can see behind me, this is our Mission Control Center. And over there, you can see the route. I think you can see there's Ahmedabad. My finger's in the right place. And over here, this is the Mission Control Center. All of those people that you'll have seen if you've been following the progress of Solar Impulse on the round the world flight attempt. And they're already getting ready for the next flight. But let's head back today. And I know that you're all waiting to ask questions. I'd like to start with the Aditya Birla World Academy. So if you could just say hello to me to make sure we can hear you.
Yes, we are able to hear you.
Great, thank you very much. So let's get the first question for André Borschberg from the Aditya Birla World Academy.
Sir, I'm Ushman Lalata. So my question is, what backup power sources does the solar pulse 2 have to run the stored energy?
Okay, I'll just repeat the question for André. Let me just repeat the question, André. What backup power sources does Solar Impulse 2 have if it runs out of stored solar energy?
We have no other. First, good afternoon and good morning to everyone. It's a pleasure to be on this hangout and talk to so many students and fabulous schools there. So coming back to your questions, there is no other source of energy than the solar energy. But you know, we believe it's sufficient for different reasons. First of all, it's interesting to see that solar energy is a very reliable source. Of course, assuming that we have a good weather, and this is given, and the route is provided by Monaco. Can you hear me?
Aditya Birla, can you hear André Borschberg?
Would that be okay for you?
Aditya Birla Academy, can you confirm that you can hear André? Hello, this is Connor speaking to the students from Aditya Birla. Can you hear our pilot André Borschberg clearly?
Yes, so we can't hear the pilot clearly, sir.
Okay, André, I'll just repeat your question because I think there's a lot of sound there. André Borschberg was just saying that there are no backup power sources. There's only the sun, but the sun is a reliable source of energy. André, I'll just head back to you again in Ahmedabad if there's anything else you wanted to add to your answer.
Yeah, just ready to add another thing is that we have quite a lot of redundancy on this airplane. So we designed it so that if we have a single failure of one system, we can continue flying, we can continue the mission. So it's through the reliability of the source of energy and the reliability of the aircraft itself that we believe it's sufficient.
Thank you for your answer, André. And I hope you're able to understand that answer. If you do have any problems, by the way, any of the schools, the best thing to do is to open the group chat. You can see the group chat icon on the left of your screen. If you click that open, just send me a text and I'll try and answer any of the questions that you send via text, because I know it's difficult with all of the sound in the hangar. Lots of people have been gathering in Ahmedabad to see the plane. Let's head now to the second question from Aditya Birla Academy. Second question, please.
So the second question is, what are the challenges you faced in your first flight of Solar Impulse 2?
Okay, André, this question is, what are the challenges, the main challenges you faced in your first flight with Solar Impulse 2?
I'm quite sure that I told you that they sent me, I've already taken out.
You know, it's the first leg of Flight Around the World. It was very difficult to make the airplane fully ready, as it's very complex airplane. So all the engineers worked day and night to make sure that the airplane was in the best position and perfect configuration to make the flight possible. So technically it was very hard. The flight itself was not a long flight, as you know, that we fly over the ocean. So it was more to get used to find the way to really fly on one side, but also live on the other side, because this airplane will become our home. It's a flying home, as we fly for so long, and you have to make this home a happy home and an easy to use home. So that was in some ways the goal of the first flight.
Thanks for your answer. And one of the biggest challenges we saw for André in his first flight was finding his spoon so he could eat his breakfast. But did you find out where it is now, André?
Always my bottle now.
Okay. And we'll just go to the third question. We are just going to have to keep it to 3 questions. So if you could choose, Aditya Birla Academy, choose your third question, please. And of course, you can listen into the questions from the other schools. So third and last question, please, from Aditya Birla World Academy.
Hello, sir. Hello, sir. Yes, is there any potential for increasing the solar panel efficiency?
Okay, I'll repeat the question. The question was, André, is it possible, is there potential to increase the solar power efficiency on Solar Impulse 2?
It is always possible, but you know, interestingly, what makes this airplane special is that it uses very little energy to fly. So it's a very efficient airplane. And the project, in fact, is more about energy efficiency than anything else. And as it is so efficient, we can fly through the night with the energy we collect through the day. And this efficiency, we'd like to propose it, to transmit it to all the applications we have on the ground, because we can make our world more efficient. We can make our buildings better insulated. We can make our car more energy efficient. We can make our lights more efficient, and all these technologies are in the airplane and can be used in on the ground.
Thank you very much, André. Thank you, Aditya Birla. So stay with us, students from Aditya Birla World Academy. And we're going to head now to our next academy, over to Hyderabad. It's in Hyderabad. Can you hear us, Hyderabad?
Yes, we can.
Great. Okay, thank you very much. Okay, let's have your first question, please.
André, first of all, comment vous appelez?
You're speaking French as well. My name is Connor, and you missed the introduction. I think you joined us a little bit later. Let me just repeat for you what I said to the other schools. If you have any questions, regarding this Hangout, please send me an instant message. We have a group chat open on instant message, so it's probably best if you could send any comments via group chat. I think that'll make it easier for all of us. So I can hear you fairly clearly. We don't have your questions in advance, so please speak slowly and clearly, because our pilot André Borschberg is in a very busy place. Okay, so 3 questions. Let's start with the first question, please.
apart from needing more solar power, hence more area, is there any other reason for the huge wingspan, or can you elaborate on the wings of the plane, please?
Okay, André, I'll just repeat that question for you. So the question is, why does the wingspan have to be quite so enormous, bigger than a Boeing 747? Is it just to get all the solar cells on, or is there another reason?
Now, you know, the main reason is to make the airplane efficient in terms of its aerodynamic characteristics. Simply said, large wingspan or long wingspan gives you more lift, less drag, and therefore lower losses. So the airplane flies with very little energy with such a big wingspan. Of course, assuming that the weight is small as well. So the challenge was to build this airplane so big, but with the weight not exceeding a car. But the consequence of it, of course, is that the surface of the wing is more important, and we can integrate more solar cells. But this was not the reason. The reason was to make this airplane energy efficient.
Okay, so André, just reiterating the fact that this isn't just a project about solar energy, it's also a project about energy efficiency. This plane has been made as light and as efficient as it could possibly be, and this is part of the message that Solar Impulse wants to spread. So that's a good answer for you, I think, not just for the solar cell efficiency, minimum drag, maximum lift. Okay, can we have the second question, please, from Hyderabad?
Hello. What's the feasibility of commercialization of this technology and engineering? Can we have rights and things like that?
So I think I understood that you want to know if there's a commercial application. Can we see commercial solar airplanes? Is that correct?
Yeah.
Okay. Well, we've got our second pilot here. I'll give André a break, and we'll bring in Bertrand Piccard, who's just arrived. Bertrand, hello.
Yes, hello. No, I'm here since 10 minutes, but I don't know why everything was muted and nobody heard me.
Okay, well, I've just been given the message now that I'm glad to hear you, Bertrand, loud and clear. So did you hear that question? Would you like me to repeat?
Repeat, please.
Okay, so the question was, Bertrand, and this is from the BITS Academy in Hyderabad. They would like to know if there's any commercial application for Solar Impulse project.
Well, I think it's a really good question because it allows to clearly explain why we do this project. We actually don't do this project to make a revolution in aviation. We use this project to show that we can achieve incredible things with renewable energies, with clean technologies, and that all these technologies, if they help an airplane to fly day and night with no fuel, of course they can be used on the ground to make a huge difference in terms of protection of the environment, new clean technologies on the market, also to create jobs, to make profit for the industry. So it's really a way to bring awareness to the people that today we can be much more energy efficient and save a lot of energy and natural resources.
Thank you very much, Bertrand. And we have one last question for BITS in Hyderabad. Could you send that question to us now, please?
Can you elaborate on the factor of safety used in the design of the plane, and can you shed light on the dynamic response of the wings, like flutter, buffeting, etc.?
Okay, can you just repeat the question, please? If you could just make the question a bit shorter and speak a little bit more clearly.
We want to, if you can explain a little more about the design of the plane in sense of shed some light on the dynamic response of the wings, like flutter and so on. How do you take care of such things? Factor of safeties, so on.
Okay, well, this is perhaps an answer coming from André Borschberg. André?
Yes, that was an important question when we did the design. And of course, what we had to do, because the airplane is difficult to build, complex, very big, we did a lot of simulation and calculation. So we calculated the all frequencies of the entire structure. We made models to make sure that we were away from the frequency that we would create flutter. And then we also tested the airplane on the ground to make it vibrate and measure these own frequencies to see if the model arrives. And of course, then we did some flight tests. The flight test, we can do the same. So it was, it was the same technology, the same principles that are used to design the Airbus 380. And in fact, interestingly, also with the same team who did the flutter analysis and flutter test on the Airbus 380.
Well, thank you, André, and thank you to the MITS Academy in Hyderabad. And stay with us. We will have more questions from the other 3 schools, academies that are with us today. And the next up is Sardar Birla Academy. Hello, Sardar Birla. Hello, Sardar Birla Academy. Can you hear me?
We have to check if we can use it.
Sardar Birla Academy. Can you hear me? This is Connor from Solar Impulse for the students at Sardar Birla Academy. Can you hear me? Okay, I've got you now. Okay. This is you in the lecture hall, is it? Give us a wave just to make sure we got the right school. That's you. Okay, we've got you now. Thanks very much. Right, and I know you've got these questions prepared already, so let's start with the first question, please.
Yeah, I want to ask that maximum angle of 5 degrees. So how did you select it as a constant? Either by a pendulum effect of the fuselage or by wing loading?
Okay, you cut out there. If you could repeat the question, please. Speak slowly and clearly.
Yeah. The SI2 has maximum bang angle of 5 degrees. So how did you select that angle? By the pendulum effect of the fuselage or by the wing loading? What constraint do you consider for that?
Okay, you were breaking up there. What I did manage to get from that was you wanted to know why the maximum bank angle is 5 degrees. If you could just nod your head if that's right.
Correct.
Yeah? Okay. Let's see, who would like to answer that? Bertrand, we haven't heard much from you. Let's see if you could answer that question for our students, please. Why is the maximum bank angle 5 degrees?
Because it's an airplane that has a very, very long wing, big wingspan, and flies very slowly. So if you bank too much, you have the inside wing who doesn't have enough speed, and the outside wing who has much more speed comparatively to the inside wing. And this differential makes the risk of entering a spin. So this is why we have to be very careful with the angle of bank. And we have a special instrument which has been developed by our partner Omega with little LED lamps on the side of the cockpit instrument panel. So if there is 1 degree, it's 1 light, 5 degrees, it's 5 lights, and above 5 degrees, it's red and it's vibrating on your arm with a special handcuff, arm cuff. And this alerts you that your bank is too steep and you can correct before you have a problem.
And supplementary from me, Bertrand, have there been many times in the flights with Solar Impulse 2 where that 5 degree angle has been exceeded, or have you and André managed to keep it always within those limits?
Well, normally when we are careful, we keep it within these limits. What we notice is that when we make some photo sessions, sometimes we have to adapt our course for the good angle of the camera. And then it's easier to have the 5 lamps flashing and be at 5.5 degrees, and then we say, okay, and we correct it. But in a normal flight, there is no special situations when we exceed that angle of bank.
Okay, and hello to all the people who are watching behind Bertrand there as well. And I hope you're getting lots of useful information from this. We have 2 more questions from Sardar Birla Academy, so let's take the second one now, please.
Yeah. When you first started off with the project, how did you go about building the right team? How did you convince them to be a part of such a big project?
So how did we convince, let me just see if I understood that correctly. The line isn't very good. You're saying how did you convince partners to be a part of the project? Is that right? Please confirm.
Partners as well as the technical contributors to the project.
Okay, right. So I'll just relay that to Bertrand in case he wasn't able to hear the question. Bertrand, the question was, how do you manage to convince people, the partners, to contribute to this project and help make it a reality?
Each of the partner came because we share values, we share spirit, which means that we cannot convince somebody to come. The people who don't have the right spirit will never come. The people who are short-minded, the people who are afraid of the unknown, the people who are only focusing on their habits and conventional way of running business, they will never come in that project. The ones who come are the ones who are open to innovation, to new ways of thinking, to new technologies. And this is why I have a lot of respect and a lot of admiration for the partners of Solar Impulse. They are really great people, and we are doing great things together. Too bad for the others.
Yes, we won't talk about them, just about the ones who are with us and Solar Impulse, and there are around 80 in all, and without them, this project just wouldn't be possible. Last question, please, from Aditya Birla.
From a technical as well as the human point of view, how difficult is a transoceanic flight? How different is from a normal land flight? And what special measures would be introduced in the trans-Pacific flight?
No, still couldn't hear you. Could you please write the question in the instant message? That's probably the best way to do it. Are you able to open up the instant message on the left of your screen? Seems like it's quite a long question. Okay, nearly done. Okay, it still hasn't arrived. So we're trying to say the question again, but as I say, if you could speak very slowly. Here we go. Well done, Pravin. We got there in the end. So the question is, from a technological and human perspective, how different is a transoceanic flight from a regular flight? And who would like to answer that question from André and Bertrand? Have we got André back? Or Bertrand? Who's it going to be?
Can you hear me?
Okay, André.
Okay, I can start. So what we have to realize now is that we have an airplane which is sustainable in terms of energy. The airplane can fly 1 week, can fly 1 month, and the crossing of the ocean will last almost a week. So the main question is, we are alone in this cockpit, of course, that you see behind me, is how can we make sustainable ourselves? So that's the major difference with normal flying, is that we are here in this cockpit for 5 days, 5 nights. So you have to learn, in fact, and you have to train how to rest, how to sleep, how to eat, how to meet all the natural needs. We plan to sleep by a period of 20 minutes only, because that's the maximum time we can let the airplane fly by itself, if I can say it this way. And after 20 minutes, we have to check everything, if everything is in order. We believe it's just sufficient to rest. But next to it, we use other techniques. Bertrand is using self-hypnosis. I am using since many years now yoga, meditation, breathing techniques, which I'm using daily for my personal balance, but which I train as well with a yogi from India, by the way, which I train specifically for this flight. So we have postures in the standing cockpit which help us to keep fit to stay fit, to maintain the organs functioning, because you need to be able to digest in the intestine. You need your mind to rest as well, and that's what we believe will help us. But as long as it's not done, we don't know. So that's in fact the big question mark we have. That's the challenge. That's the exploration we need to do.
Okay, Bertrand using yoga, so André rather using yoga techniques, and if you want to see some photos of André preparing for the next flight with his yogi, who's here with him, then you can go on the website solarimpulse.com. And as you said, André, Bertrand uses self-hypnosis techniques. Bertrand, these self-hypnosis techniques, you've been using them for quite a long time, haven't you?
Yes, it's true that I use self-hypnosis already in 1992, 23 years ago, when I crossed the Atlantic in a balloon. And then in 1999, when I flew around the world non-stop in a balloon, that was 20 days in the air. And why is self-hypnosis so important and so efficient? It's because self-hypnosis allows you to turn your awareness from the outside, which is the usual type of awareness we have, to the inside. So when you are inside of yourself, you can disconnect from the stress of the outside. You can focus on your emotions, focus on your feelings, focus on your concentration, and this allows you to be much more efficient in this type of situation. Sometimes you can even cut your body from your mind, and your body can sleep, but your mind is still alert to see what there is in the plane and to control. So I found it quite efficient for me as a technique.
And for most of us, when we're in a very stressful situation, a very stimulating situation, it can take us a long time, an hour, 2 hours before we can get to sleep and really relax. With these self-hypnosis techniques, Bertrand, how long does it take you to go from being completely in charge to being in that completely relaxed state?
Well, it takes maybe 3 minutes to be in a complete relaxed state. It does not mean that I will necessarily sleep, but it means that I will be so deeply relaxed, so deeply into myself, that the energy can be regenerated into the body. So this is something that I found so interesting. You don't always need to really sleep in order to rest and to be regenerated.
Well, thank you for that answer, and thank you very much to all of the students at Sala Birla. We have 2 more academies, and we're going to go to the 4th academy now, which is Pilani. Hello, Pilani. Can you hear us, Pilani? Just say hello if you can hear us.
Hello, can you hear? Yeah, we can hear.
We can see you all there, okay. And there are lots of you waiting in that lecture hall. And just to remind you, you have 3 questions for the pilots. And can we get the microphone to the student with the first question, please?
Already. Hello. Can you hear us?
Yes,
I
can hear.
So our first question is regarding the designing ideologies between the SI1 and the SI2 plane. What is the difference in the designing ideologies of the prototype and the final plane for the round the world tour that you're having? And what are the technological constraints that you face in both of them?
Okay, so the question is, what are the differences in the design ideologies over the first prototype, SI1 and SI2? Were there any different, was there different thinking behind the designs of both planes, and major technical improvements in the second plane over the first? So, well, let's start with André, and then we'll bring in Bertrand after that. André.
First of all, the major change we made was to make an airplane which is a bit more stable. Because stability, you know, when you let the airplane fly by itself, to see if the airplane stays and comes back to a horizontal attitude. So we believe that for long flights it was very important. So that's number 1. Number 2, of course, we introduced new technologies, and these are more efficient solutions. We have carbon layers, for example, which weighs 1/3 for each layer of the weight of the sheet of paper that you have from your printer at home or in the university. So extremely thin, extremely light. So this is what we used on the second airplane. And the third difference is that that's an airplane to travel long distance. So the ergonomy of the cockpit allows the pilot to live a long time. And we have instruments to help the pilot supervise the airplane, like arms or systems vibrating in the arms to trigger, I mean, to alarm so that you can make.
Is it possible just to very briefly major design constraints?
I did not answer. I did not understand the question.
Okay, it's very noisy where you are. I just wanted to ask you, André, if you could give us one or two of the major design constraints in the construction of Solar Impulse 2.
You know, the most delicate part was to certify the airplane to allow it to fly over the major cities of the world. Experimental airplanes normally fly over the desert. If they crash, we rebuild one and we retest. Here we cannot allow that, of course. So this experimental airplane is very reliable. And this has, of course, imposed a lot of constraints on the design, imposed redundancy, imposed safety measures, which on one side has maybe created more weight, and therefore a penalty in terms of performance, but on the other side, it made it safe to fly and land in Ahmedabad, in Varanasi, Somaliland, but also in New York, when we will end up on the east coast of the United States.
And Bertrand, I'd like to bring you in on this one, the differences between SI1 and SI2. In terms of piloting the plane, have you noticed any major differences?
Well, SIA, the first one, was an airplane that was built in order almost to train to build this type of experimental airplane. So of course everything was very much simpler inside. There was not as much reliability, not as much redundancy. The cockpit was much smaller. It just allows to fly, I would say, overland for maximum 26 hours, as André has done. Solar Impulse 2 is an airplane that is made to cross oceans. So the cockpit is bigger. There are toilets on board. You can have the pilot lie down. You take more food. You can really stay up there for maybe a week. So this makes a very big difference. Now in terms of flying the airplane itself as a pilot, you have more power and you have a little bit more stability.
Okay, thank you for that answer. Okay, back to Pilani. We have two more questions left. Let's have the second question, please. Second question, please. Can you still hear us, Pilani?
Sir? Yeah. Can you hear us?
Yes, I can hear you. And I'm speaking to Aman. Is that right? Aman Khurana?
Yeah. So our second question relates to the technology, energy technology. So what do you think is the current status of the solar energy technology, and what breakthroughs are required in maybe in the battery technologies and solar cell efficiencies to promote the use of solar energy further, and specifically to solar technology and specifically to Solar Impulse project as such?
Now that's a great question. Well, it's a multi-part question, but to boil it down for both our pilots, I think, what is the next technological breakthrough, whether it's battery power, solar cell technology, that's really going to make a difference, a major step change in the adoption of the amount of solar technology that we use around the world? I'm wondering who we could start with on that. Maybe we'll start with André and then bring in Bertrand. André, so do you have an answer for that one? I know it's quite a big question, but we're looking into the future, aren't we? What do you think is going to be the next technological breakthrough for renewable energy and solar energy in particular?
I think first we have to understand that the revolution is already behind us. Because what we had is that the Germans have developed the technologies, the Chinese have started the production at a very low cost. They are number one in solar, and solar energy now is at the price of the other source of energy like oil and gas. I'll give you one example. In Dubai, they are now building power plants, and the cost to produce electricity out of solar will be 5.9 cents a kilowatt hour, when the cost to produce 1 kilowatt hour from oil or from gas is above 7. So of course these are countries which are rich in sun, but you can already see the difference is positive. So I think the revolution is done. Of course we can improve, but what we need now is more, in fact, first the awareness to make sure people understand that, but second, I think Bertrand will expand on this, government to really make sure that this technology are used, because they work and they are economical.
Okay, so as André is saying that the revolution is already behind us, we're seeing the price of solar technology fall constantly. It's getting cheaper and cheaper and easier to install solar technology in all parts of the current economy. You mentioned also the role of governments, and I want to bring in Bertrand Piccard on this one. It's not just technology, Bertrand, it's also about mentality. Bertrand, are you with us?
As much energy.
Okay. Okay, sorry, Bertrand, your microphone was muted. If you could just start the answer again about mentality, please.
Yes, I was saying that solar energy will never be enough in our world to fulfill our needs as long as we continue to waste the energy as we do today with old technologies that have too many losses and not enough efficiency. So we have to understand that to make renewable energies a reality worldwide, we also have simultaneously the need to implement clean technologies in the engines, in the insulation of buildings, in the lighting systems, in the heating and cooling systems, in the industrial process. We have to save energy everywhere. And if we do, because it's possible to do it, then solar energy and wind energy will be enough for the world.
And of course, government has a major role to play here as well in terms of legislation in this area.
Yes, because today it is still allowed to pollute. It is still allowed to waste energy. It is still allowed to put as many CO2 as we want in the atmosphere. And as long as there are not clear guidelines, legal frames and regulations, it will never change. So we need now several things. We need to put a price on carbon, as we have for the waste. And we need also to replace the old technologies by new, cleaner technologies, have more electrical mobility, have better insulated houses, have LED lighting systems. And if we do that, we will see that not only renewable energies will be enough for the world, but it will also create jobs, it will also make profit for the industry, and it will create wealth. So for developing countries or emerging countries, it's a must. It's an absolute must to go into that direction.
Okay, let's have the last question, please, from Palani. Last question, please.
A last question relates to the solar impulse project. What do you perceive as a future of the solar impulse project after the round world trip and in the later years, in the years to come? And also, how do you solve the icing problems?
The icing problems, is that what you said? Problems with icing?
Yes, sir. And the future of the solar impulse project.
The future of the Solar Impulse project. Well, the future of the Solar Impulse project, first of all, that's a very open question. I'm sure the pilots are going to say that they're concentrating on getting through the round-the-world flight step by step. But well, let's see what they say. And we'll start with you, Bertrand, and then take in André. Let's get your views on the future of the Solar Impulse project. Bertrand
there are two
first.
parts. André is going to, yes, there are two parts. André is going to speak of something interesting that we're preparing. But one thing I would like to emphasize is the fact that Solar Impulse has a legacy in terms of bringing people together, raising their voices in favor of clean technologies on the political level. And we have now a call to action on our website. You can go, each of you go on solarimpulse.com and you click on the left on the part which is written Future is Clean. Future is Clean is our call to action. And you can agree to have concrete actions for a clean future. If you agree, then you can leave your email address or Twitter or Facebook address, and then we will have all these voices from every country. We will know which country has made the biggest effort in terms of raising their voices, and we will go then to the governments and show how many people care about clean technologies. And if we have millions and millions of voices, we can make a difference, because the governments will need to listen to this population if they want to be re-elected. It will be part of the political program to care about clean technologies and clean future.
And you can do that right now. You can go on to solarimpulse.com and follow the link to this movement, which is called Future is Clean. It's futureisclean.org, and you can sign up. As Bertrand said, we're looking for millions of people to join this. We just launched it just a few days ago, so you will be some of the first. So all the people who are in this Google Hangout, we hope that you're all going to apply as soon as we finish the Hangout. Tell all your friends, tell all your family, and we're going to start this movement rolling now. And let's hear from André as well about what he can tell us about the future of Solar Impulse.
So, when speaking of we can do with the technologies we have, and what you see behind me with this airplane is to build such an aircraft without a pilot, so completely unmanned, automatic control from the ground, which could fly at 20 kilometers altitude, so above the altitude of the airliners, which could fly for 6 months, for example, over a major city, let's say Delhi, which could provide communication services. So this will be a very simple way to replace satellite, but of course cheaper, more affordable, more sustainable. So that's something which can be done, I guess, in the next 5 years. You surely know that Facebook and Google have hired teams to do this. So there are a lot of groups, companies around the world who are working on this kind of technologies. And I believe, for this kind of application, this can be a great future.
Okay, and there was a bit of noise there, Pilani. If you weren't able to understand everything that André was saying, basically talking about one possible future application with all of the technology and the expertise that André and the team have built up over the last many years working on this project, is the possibility of using solar-powered drones for communication purposes, replacing satellites much cheaper than satellites, and that's one possibility. But this is all looking into the future. We're going to really be concentrating on getting this plane, getting these pilots safely around the world, and breaking a record. First time a plane has been traveling around the world using only solar power. Let's now go to Goa for the last 3 questions. Goa, can you hear me? Hello, Goa. Right, okay, Goa, we can't hear you very well. Now, I've been asking the other schools just to also write the questions in the instant messaging service on the Google Hangout, because the sound quality isn't fantastic. But let's see what we can hear now. So let's hear from Goa. Give us your first question, please.
That's the plane. Emergency backup power source in case of a circuit failure.
Right, do we have the teacher in Goa? If the teacher in Goa could help us out, repeat the question nearer the microphone, because it's very, very difficult to hear you all. We can see you all, but we need to hear you. And I think the student is coming closer to the microphone, so let's hear that question again.
Should I start? Does the plane have an emergency backup power source in case of a circuit failure?
Okay, we didn't hear that. I understood the question was, does the plane have a backup in case the solar power doesn't work? Is that correct?
Yes.
Okay, so well, let's start with André on this one. André, is there a backup? Imagine for whatever reason there's a problem with the solar power. Is there a backup in solar impulse?
I will answer the question, Connor, but I think we'll have to leave after this question is there, because
okay.
Some other people are waiting after me. But
that's fine.
for these questions, what we have in fact is full redundancy. We have 4 motors, we have 4 battery systems which are independent, we have 4 area for solar cells. So if we lose one of these, and if we lose a motor, we can still continue to fly. We can use the batteries of the other motor to a system of cross feed. So with these redundancies, we are quite flexible, and that's the way we cope, in fact, with the risk. That's the way we cope with these long duration flights. But there is no other source of energy. There is nothing else but the sun. But the sun is extremely reliable, as I said. I mean, we have the sun every morning, we recharge the batteries. Solar cells, they work 25 years, 30 years without any problem. Electric motors are quite reliable as well. It's better than a thermal engine. So from this perspective, but I touch wood of course because the airplane is very new, the reliability we expect it to be appropriate and sufficient to burst the ocean.
Thank you very much, André. Thank you for being with us in this Google Hangout. André has to leave us now, and we do still have Bertrand Piccard, I'm glad to say, who can help with the answers to the last 2 questions. Go on.
Can the plane land safely during emergencies on any terrain? Does the aircraft require a longer runway to take off, considering its low speed?
Okay, Bertrand, you've got 2 questions in one there. The first one was, can the airplane land in any terrain? The second question is, does the plane need a longer runway because it's so big?
We need a wide runway, but not a long runway. We can take off and land on 200 meters because we fly slowly. But of course, we need no obstacles on the left and the right, otherwise we would touch with the wings. And we cannot land in the grass. We need a concrete runway because the gear is very light and would not cope with grass or earth.
So maximum of, yes, around 200 meters for takeoff, Bertrand, and I know that depending on wind conditions, it can even be less than that. Could you tell us what do you think was the shortest takeoff that you've ever had?
There was a couple of test flights where quite a lot of headwinds, and I think the airplane once took up in 50 meters, 50 meters, it was already in the air. But that was with the first prototype, not the second.
Okay, well, Bertrand, we've got one more question for you, and then we're going to let you go on what is a very, very busy day for you. So the last question, please, from Goa, and please make it a brief question, just one question, and it could be a short one, please.
Yeah, the maximum speed of the Solar Impulse 2 is about 150 kilometers per hour. What prevents the plane from attaining higher speeds?
Okay, so there's an easy one for you, Bertrand, I think. The maximum speed, 150 kilometers an hour. What prevents the aircraft going even faster?
When we speak of 150 kilometers per hour, it's at high altitude when we have to make an emergency descent. But if we want to fly horizontally, the best is 35 knots, which is 45 kilometers per hour. And if we want to fly faster, twice faster, for example, we would need to collect 8 times more energy, which we cannot do. So this is why we have to choose between speed and duration. If you choose speed, you need a lot of fuel and you have to refuel all the time. That's conventional airplanes. Or you choose duration, like solar impulse. You fly forever, but with less energy and at a much slower speed.
Well, thank you very much, Bertrand, for being with us on this day. And do you want to say a final word before you head off to your next meeting?
Yes, yes. There are a lot of students from universities and academies who are listening to André and I today, who are interested about solar impulse. And you have to really understand that if you have a dream, if you would like to achieve something in your life, it's like for us, it's a big adventure. It's not always easy, but we have to try. It's worth trying. And sometimes the adventure in life that is about going to school, going to university, changing job, moving house, or inventing something new. But all this is worth trying, because life is not interesting because what we have. Life is interesting because of what we learn. And I wish you to learn a lot of things and to have a great future and to enjoy it and to be also explorers of your future. So good luck to everyone.
Thank you very much, Bertrand. Thanks to all of you. And a reminder that Solar Impulse landing in Ahmedabad, it's the first time there's been a solar plane, not just in India, but in the whole of Asia. And there are public visits tomorrow in Ahmedabad from 7:30. To find out more, go to solarimpulse.com. And don't forget as well to sign up to the Future is Clean worldwide movement. We're looking for millions of people, and we're counting on you to be our pioneers, to be the first ones who are taking part in Future is Clean. So again, solarimpulse.com, and we are now going to start preparations for our next flight, leaving Ahmedabad in a few days' time. We don't know when exactly, and after the events taking place in Ahmedabad, heading to Varanasi in Uttar Pradesh. So thanks again to all of you, and goodbye, and we'll see you for the next Google Hangout.